Hello guys, this is Al.Mahdi and today I will be talking about question 2. Sorry for the delay, since the doctor did extend the deadline, then I think it's fine, but let's do this. So the question 2 says the following code shows part of a VHDL listing description for the synchronous state machine. The first part of the question said, complete the description by writing down the synchronization process. Okay, it says process, right? Okay, with an asynchronous reset signal. The asynchronous signal is gonna make the state back to A upon reset, right? Okay, now let's do this fast. Let's go ahead and check the code. Okay, we have the importing the library, we have the entity. Alright, the entity, we have clock and reset as an input, we have 20 and 10 as an input, we have ready and dispense and ret, I think it means return, and coin as an output. Alright, and we have the architecture for this entity. We have a type of we're initializing a type. Actually, we are initializing a new type in this to create the state, and we're naming the type state type, and we're giving the type 6 values: A, B, and C, and D, and F, and I for the state. So basically right now state is A, B, C, D, F, I. Alright, as a data type. So we are defining over here a present state signal and a next state signal, and we're giving it the type of state type, meaning that the present state and next state gonna have 6 different values, possible values, which is A, B, C, D, F, I. Alright, so not like STD logic. STD logic is predefined from the library, right? Predefined data type which have ZX, U1 and 0, and so on. Anyways, moving on. So from the question, he said to complete the synchronization process, right? Okay, and he gave us a count here. We should do the synchronization statements over here. Alright, let's do this so fast. I think I'm gonna just write it down over here. So basically what he's asking you to do a process. I'm gonna name it P0. Okay, so P0 is gonna be process. Okay, and it's gonna take 2 things. Since from the question he said, let's go up. From the question he said asynchronous reset, meaning we're gonna need the clock first to be in the sensitive list, and we're gonna need also the reset. So whenever the clock changes or the reset changes, then this process is going to be triggered. Alright, so P0 is equal to process, and it is going to take the clock and reset as a trigger signals. Okay, now we're going to define simple things. Begin. I think I did it wrong. Let's just begin. Alright, you're gonna begin over here the code. First you're gonna check if reset is equal to 1. If reset is equal to 1, then what you're gonna do is gonna do the present state, present underscore state is gonna be assigned to A. Alright, else if rising at is the clock, right? Then what are you gonna do? If not reset, then it's gonna take the next state, where from the question, if you see over here, if you see the code down here in the second process where it have the sensitive list as the 2010 and the present state, then you're gonna see in different state, let's say if you the reset is gonna go to state A, right? And the next state is gonna be assigned as it depends on the if statement, alright? So if the 20 is 1, is gonna go to next state D. The next state is gonna be D. So over here, the clock, the present state, is gonna be assigned to the next state. Okay. So if you imagine you have this chip, alright, and you have this is, let's say this is the D and this is the Q. If you remember the code, the Q is gonna be assigned to what? The D, right? Let's assume this D is the what? This is the next state. Just change the name. And this is the present state. Then it's gonna be easy to know how did I get this from. So the Q, just replace it to present state and assign it to the next state. I think I misspelled it, but you got the idea. Anyways, let's just finish this off. We was doing this, okay? So at the end, we're gonna do the end if and semicolon. So we ended the if statement, and we need to end the process, end process, and the process name is P0. All right. So this is the first part. You're gonna code it later, but if you remember how the reset is asynchronous, isn't it? Imagine this is asynchronous reset. So basically, you're gonna do, if it it's not active low, it's active high. So basically, there's no bubble over here. So right now, if the asynchronous reset is 1, then this is gonna be state A. The value over here is gonna be the state A. All right. So you can imagine it like this, but let's just do this. Okay, I'm just gonna clear this thing. Just make sure that you know how did we do it. We're just gonna do it again later by coding it. Okay, let's just clear this out. So right now we got the idea of how to do how to complete the coding. Alright, now next question is asking you to draw the state diagram and to draw the state machine the algorithmic state machine, the ASM. I don't know if I pronounced it right. Okay, to describe the state machine. Well, basically what we're going to do for the second part of the question, all you need is to know how to read this. Yes, how to read this statements. If you just, I think the easiest way to do it. Okay, let me just, I don't know what's happening. Okay. All right. If the easiest way to do it is go and check what is the state names. We have this, like, go from here and check how many states you have. Okay, we have A, B, C, D, F, E, I. Just write them down. A or A. Okay, B, C, D, and let me check again to make sure. D, F, I. F and I. Alright, so we have all of those states. Let me change the color, make it red. To make the arrows, you're gonna need to refer to the coding. Let me just make this whole thing. Go to the question. Go to this and check what is state A doing. So here, it's giving an output for ready. So over here is giving you ready. All right. Just go to the other things, so the other states, and check what is the output for each one of them. Is giving you ready, is giving you dispense as an output. B, dispense. I don't know if I do it right. Go back and check this again. B, C is giving you coin, D is giving you a coin, and F is giving you a coin, F is giving you a coin, and I is giving you a return. Okay, so C coin, D coin, and I is what? Ret. Okay, this is the outputs for each of them. So how to connect them? How to know how they relate to each other? Let's go here. From here, you can see if 20 is 1, it doesn't matter how much is 10. The priority is for 20, right? So if 20 is 1, no matter how much is 10, is gonna go to D. So you do it like this. Just take the black color, just in case. Yeah. From B, let's go check again. Oops. If 20, let's do this. 20. Okay. And the next one is gonna be 10. So basically, this bit, the most significant bit is 20. The least significant bit is 10. Just describing it in a way. Okay, let's just go back here. If 20, then go to D. 20, go to D. So most significant bit is 1. Doesn't matter how much is 10, is gonna still go to D. Else, let's go ahead and check again. Else, if 10 is 1, that means this is 0. If 10 is 1, then this is 0. Then because this is else if, right? Else if this is not 1, then it's gonna go here. And if the 10 is 1, is where it's gonna go? Is gonna go to the C. So go to the C if you have 0 and 1. What if it's 0, 0, right? Okay, let's go ahead back here. What if it's 0 and 0? Else, go back to what? 0, 0, go back to A. So it's gonna do a loop back. So 0, 0. This is the first one. So let's go ahead and do the next one. So when B is gonna give us, we already did that. It's gonna go directly. There's no if or wherever. It's gonna go always to A. So this is gonna be always to A, X. Doesn't matter what values there are. So here we go. From C, okay, if 20 is gonna go to F. So if 20 is gonna go to wait a second. C is if 20 is gonna go to F. So basically it's gonna go like this. If 20 is gonna go to F, means 1 and X. Else is gonna go to D. So D if 0 1. All right. Okay. Else is gonna go back, loop back to what? To itself. So if it's 0 0, it's gonna go loop back to itself. So let's go down a little bit and check for the next state, for the D state. The D, if the 20 is 1, is gonna go to B. 20 is 1. The D is 20 is 1 is gonna go to the B. If 1 and this is X, right? Okay, go back here, go back here. Where is that? Where is it? Okay. Now, if the 10 is 1, it's gonna go to F. So it's gonna go to F if we have 0 1. Else, let's check the else again from the question. Else is gonna go back to itself. It's gonna do the loop thing. 0 0. We're building up the state machine. I mean the diagram, state diagram, and we're like being familiar how it's gonna work right now. So basically, right now, if 10 is gonna go to if 20, I mean, is gonna go to I. Else if B is gonna go to, I mean, if 10 is gonna go to B. Else is gonna loop back to itself. So basically, it's gonna go to I if 20 is gonna go to B if 10. We was checking F, is it? Yeah, F is gonna go to I if oh my, I just forgot. F is gonna go I if it's 20, B if it's 10. So I if it's 20. So 20 is 1x. Doesn't matter how much is 10. Else is gonna go to B. It's still a little bit messy over here. Else is gonna go back to itself. 0 0. And let's check the last part, which is I. Okay, wait. Okay. I is gonna go directly to A, no matter what. I is gonna go to A, no matter what. I think this is the state diagram. All right. So this is how it's gonna be done, basically. Let's go ahead and do the next part of the question. I'm just gonna clear this out, clearing it out. So let's do the ASM. ASM is doing, do you remember the state and the conditional and the output? Okay, those are basically, we're gonna just use those two because I think it's I don't remember how to what is the difference between two state machines. There's two state machines. One is milli and one is I don't remember the other name, but you got the idea. So let's move on. Just do this. So we're gonna do this thing. We need also to refer to the same state. So we have state A. Let's go ahead and state A. State A. Let's do this. State A is gonna give you back ready, right? And if 20 is gonna give you what? It's gonna, this is yes. Okay. If 20 is gonna go to state D. So let's do this. State D. Oh shit, sorry. Never mind. State D. So this is, oops, I'm doing something wrong. Sorry about that. Don't want this thing. Just removing it. Sorry about that. Okay. The D. So D is a coin, I guess. I already forgot. D, yeah, it gives you coin. And what if it have a 20 also? So 20. Basically, if no over here is gonna go to what? To 10, right? 10 coin. If 10 coin is gonna go to another state. So it's a little bit small over here. I hope I can know how to extend it. Let me just redo a little bit. Make it smaller. A is ready. If 20 is gonna go to, this is yes, this is no. If 20 is gonna go, okay, if 20 is gonna go to D, okay, and D is a coin output. It's gonna output the coin and makes it 1. If 20 is gonna go to somewhere else, is gonna go to somewhere else, where this is 10 coin, and I think this is also the same, 10 coin. Alright, and here is yes, here is no. Okay, oops, just make a space for the arrow. The no, let's make the no on top, because I think it's gonna be loop back, because A, if you went to back to the diagram over here, if A else is gonna go back, right? If not, is gonna go back. So I'm gonna do the no over here, the no is gonna go back to where it belongs, to the top. It's gonna go back. Okay, now it's a little bit lengthy, but then you should do for all states the same thing. Let's say A, if not, is gonna go D, else is gonna go to the C. So else is gonna, the C is gonna be over here. C. Just do the arrows, so it doesn't confuse you where it comes from. Okay, C is also a coin. Let's make sure. C is giving you a coin, and we have F, and just make it this side, okay, and F 20, and do something else. You're gonna go to 10, else not. I think you're gonna loop back, right? You're gonna loop back. Let's check. Else is gonna loop back. If 20 is gonna go to F, if 10 is gonna go to D. So how to do that? Just try to do this. Do this. Yeah, just like that. It works. Okay, now if 20 is gonna go back to, I hope I have the paper in front of me. I don't need to swipe. Next is gonna go to F. Do we have F here? No. So let's draw F, and I think F is also a coin. Make this longer. Alright, and let's do the F20 thing. F20 coins, else go to 10 coins. Okay, now let's go ahead and check again the question. It's a little bit lengthy. So what did we not finish? Okay, we didn't finish the D. The D, let's check where does the D go. Yeah, the D goes to B and goes to F. So do we have B? No. If 20 is gonna go to B, the B over here, the B is, I think, is a coin. I'm not sure. Let me check. No, it's dispense. Dispense is gonna be 1. Pens. If I spell it right, anyway, you should spell it right. And there's nothing. It's gonna go back to A. It's like, doesn't matter what is it. So it's gonna go back to A, no matter what. Alright. The F is, I think we have the F over here. So if 10 is gonna go to F, so it's gonna be like this. Alright. Okay, we have the D finished. F, C is finished also. And we, yeah, basically finished C, finished A, and D. Still have F. Let's check the F. Go back to the question. F is going to is going to go to I if 20, so it's gonna go to I if 20, and the I is, I think it's ret, which is return. I guess it's returning the coins if it's more than you need. And where is it? And else is gonna go to B. Alright, else is gonna go to B. Else this is gonna go to B. Else F10 is gonna go to B, and else is gonna go back to itself. So let's say this is no, this is the N, no, and this is the yes, and it's gonna go back to B. Okay, and here is going back to A again, just going back to A. So I think this is the complete diagram, because we have how many states? 1, 2, 3, 4, 5, and 6 states. This is the complete ASM chart. Alright, okay, I think let's just label this. This is yes, this is no, yes, no. I think I'm gonna use a different color for this thing. So yes, no, no, yes, yes, no. I think yes, no means 0. N is equal to 0. 1 is I mean yes is equal to 1 basically. You can use 0 or 1. It's better 0 and 1 since we are dealing with bits. So anyways, I'm just gonna use N and yes for now. Okay. Why? So the conditional, I think we did that well, finished that. Oh, we didn't finish this thing. Okay, this is not finished yet because we only have yes for the 10. Just make sure that it's finished. If else, let's say D, else 10 is gonna go back, I think. D in the else statement is gonna go back to the loop back to the D. So basically I don't need to do all of this, just since the arrow is like that, I can just do an arrow over here. It's gonna go over here because this loop is gonna go over here too. So yeah, it's gonna go looping. Just make sure everything have a yes and no. And I think this is all. This is the second question. Okay, third question. Let's do the third question. Third question. Let's go back. What does the third question says? The third question wants you to write a test bench for the state machine and verify it using model sim altera. I'm gonna pause for this one. I'm gonna pause the video for this one just for a while. Alright guys, I'm back. So we will do the question, the part 3 from the question 2. The part 3 says write a test bench for the state machine and verify it using model sim altera. So the first step to do is I'm gonna go ahead and open my Windows. I'm going to open model sim because I only have it on Windows. I don't know if there is a Mac version. Anyways, I'm gonna open it up. Close. I'm gonna go ahead and create a new project. From the new project, I'm gonna say yes, continue on. Browse to do it in assignment 2.1, and just gonna name it state machine. Alright, I'm gonna save. I'm gonna create 2 files. One of them is the state machine, and the other one is gonna be the test bench. Okay, I'm gonna go ahead and press OK, and now I have 2 files that I can work with. First is the state machine. State machine is gonna be empty, of course. The first step is go ahead and just copy all the code from the question. Just copy all the code from the question because you need it. Just copy it. Copy, and I'm just gonna paste it all. You can keep it a little bit, make it more organized, do the spaces and stuff. And let's go ahead and do this really quickly. Alright, so this is gonna be under the state 1. State A is gonna be ready, and if it's ready, it's gonna go ahead and change the state, else F. It's a little bit tedious, but it's worth it. I'm gonna leave this part for you. I'm just gonna leave it like this. It doesn't affect anything, but it's better to make it organized. Anyways, I'm just gonna skip this part. You do it. I'm gonna do the synchronization statements really quick, which we wrote by hand. So basically, for the synchronous statement, which we did in part A, I told you that we are going to do it again. So let's do it using the code. You're gonna do P0 and we're gonna name the process. So we're gonna have a process. Oh, okay. Process. All right. And name of the process is P0. I'm just gonna do the trick again. Okay, sensitive list. What we need for sensitive list is the clock, alright, and also the reset, because the reset is an asynchronous. Alright, now let's go ahead and do the if statement. If the first priority is the reset, so if the reset is equal to 1, then go ahead and make the present state to be assigned to A. Alright, now else if the rising edge or the rising edge of the clock. Alright, if the clock change it from 0 to 1, then what do you do is just do the present state is gonna be assigned to the next state, and the next state is depending on the input, the 20 and 10. So let's say this next is D. If 20 is 1, yeah, we just saw the ASM chart, and it's obviously easy to understand. Anyways, let's go ahead and do end F, and we have our synchronization statements ready to go. So let's save this. This is the synchronization. You can just adjust this and make it more organized. I'm gonna keep it up to you. Sorry about the notification. Okay, so let's save this thing. Go ahead and jump to the test bench where let's go ahead and make sure and compile if it's checked, and it should check. Alright, it checked, so we are good to go. Let's do the test bench for the state machine. To do the test bench, we already know that we need an entity. Alright, the entity name is gonna be test bench, state test bench, and no need for the ports. We don't need it. I'm just gonna copy this and put it here. Oops, sorry, my mistake. Okay, let's go ahead and do the architecture for this test bench. Do this architecture. Okay, and do we need signals? Yes, we do. Of course we do. What kind of signals we need? Let's go back to the state machine. We need we don't need present and next state. We only need the inputs, which is those inputs. 3 inputs and 4 inputs and 4 outputs. So basically we need those, and I'm just gonna do them like std underscore logic logic. And yes, we did forget something. We need to import the IEEE library, so we're gonna do a library and IEEE comma, then use IEEE dot std underscore logic underscore 1164 dot all. So yeah, okay, and I'm gonna initialize it to be as 0, initializing all the inputs to be 0. Alright, oops, sorry. So now we need the output signals. The output signals, we're gonna have them from here. We have the ready, dispense, writ, and coin, and we don't need to specify whether it's input or output because it's there. I'm just gonna do a simple thing. I'm just gonna label them as I for input, because we don't specify them in the in over here. We don't specify whether it's input or output, but it's easier for me to label the input as I and the output as O. Alright, I'm just gonna do this. Oops. Alright, just fast enough. Okay, now also it's gonna be std logic, and we don't need any initial value because this is gonna go ahead and it's an output. You don't need to initialize it. Anyways, now I'm gonna do the shortcut where you go ahead and instantiate your element that you want to test. So I'm gonna do G1 for the state machine. I'm gonna call the state machine. I'm gonna go ahead and say entity, and I'm gonna say under the work I have an entity called state machine, and have architecture. Let's make sure, is it no, the entity name is A2. Let's just change this, and the architecture name is ASM. Alright, now let's port map it. Port map, and just use the port mapping. I'm gonna just copy all of this, paste it for the inputs, the outputs, copy all of this, let's paste it for the output, just semicolon. I'm just gonna do a new line for this, just to make it much more organized. New line, and yeah, semicolon over here at the end. So this is the outputs, sorry, outputs, and here are the inputs. Alright. Okay, now we have initialized our gate G1, right? Now how do we assign the inputs? It's a little bit tricky. We can do the previous thing for the clock, like clock is gonna be assigned to not clock I after something, after let's say 5 nanoseconds. Alright, but there's a different way using the process method. To do it using the process method is a little bit need a little bit of thinking, but let's do this. Let's do a clock for the label. Let's just do the shortcut clock. Okay, the sensitive list is not gonna be there, so process is you gonna wait, you're gonna initialize the clock to be 0. Clock I is gonna be 0, okay, and wait for, you're gonna wait for 5 nanoseconds. Alright, and clock I is gonna go back to 1 after 5 nanoseconds, and then wait for another 5 nanoseconds. So basically this is gonna just keep looping because it's always gonna be triggered. So first it's gonna go to 1, then it's gonna wait for 5 nanoseconds, then it's gonna go ahead and change to 1, wait for 5 nanoseconds, and again it's gonna change to 0 until you, yeah, until forever, just changing from 0 to 1, 0 to 1. Alright, now let's go ahead and do the reset using the process also. So I'm gonna do the reset, and I'm just gonna do the shortcut again, process reset. Okay, just gonna put this inside here, and I don't need sensitive list, and I'm gonna go and say is okay. Right now I'm gonna do a reset I'm gonna initialize it to be as a 1, okay, and I'm just gonna wait for 5, I mean let's make it 10 nanoseconds, and then I'm gonna change it to reset is gonna change to 0, and I'm gonna wait forever, just wait, that's all. Okay, so basically I'm gonna change this to 1 after 10 nanoseconds. It's gonna change to 0, then it's gonna never change again, it's gonna stay 0. Okay, do the next signal. I'm gonna do the input, which is for the 20. Let's do the shortcut for the process the 20, 20. Alright, no sensitive list. We only need a port. I mean just the input for a signal for the input. So you're gonna say that 20i is gonna assign to 1. Oh wait, here's a little bit different. Okay, I'm gonna wait, okay, until the clock I is equal to 1. Okay, if the clock is equal to 1, I'm gonna go ahead and change the the 20 to be 1 and wait for, let's say, wait for 100 nanoseconds. Depends on how you want to test it, because I want to test it the 20 stay 1 for a whole cycle, let's say, because we have you can change this to 20. If you change this to 20, it's gonna be each clock is one state. So basically you're gonna loop for more than 3, I think 5 states while the 20 is 1. So you can check whether if it's going to the right place, whether or not. We're gonna keep it a 5 for now, and we're gonna see it in the time diagram later. So I'm gonna go ahead and just change this to 0 after 100 nanoseconds. 0, and also I'm gonna wait for another 100 nanoseconds. Okay, so I have the 20 process is already ready. So basically whenever the clock is click, it's gonna go ahead and assign it and wait for 100 nanoseconds. 20, assign it, and until it's the clock is assigned to 0 and wait for 100 nanoseconds. I think it's okay if you leave this, because it's gonna begin as a 1 and it stays for 1 for 100 nanoseconds, and then changes after 1 nanoseconds and wait for 100 nanoseconds and just loop for it. But let's try first with this, then we're gonna try it without. Okay, let's move on to the last input, which is the 10. So let's do this trick again, process, and just do the 10. And the sensitivity list, we don't need it, and it's gonna be like this. So right now I'm just gonna wait until, but right now I'm not waiting for the clock, I'm gonna wait for the 20 to become a 0. And why is this? Because if you check the state diagram, whenever 20 is 1, we don't care how much is 10. So we only care how much is 10 when 20 is 0. So if 20 is 0 until it's 0, we want to change the clock. We wanted to change it from let's say 10. Let's assign it to 1, or let's assign it first to 0. Okay, then wait for 15 nanoseconds. Alright, then the 10i, we're gonna assign it to 1 and wait again for another 15 nanoseconds. So what's gonna happen is whenever the 20 is changed to 0, then it's gonna change 10 to 0, and it will wait for 15 nanoseconds, then it change it to 1 again and wait for 59 seconds. So you can play around with these values. It depends on how you want to test your state machine. And you know, in state machine there's a lot of possibilities. I think it's really hard to test every possibility in this way. In my opinion, the best way is to, like, it's not required, but the best way is to do it inside the chip itself, so you can change the states. You cannot change it from here. Like, you cannot set the state to A or set the state to B, and you can check where does it go if 20 or 10 is 1 or 0. So basically this is a roughly good way to test, or like the way to test your test bench, but it's not gonna give you all the possible values for the output. Anyways, I think right now let's go ahead and save this thing and check if the syntax is correct. And to do that, we're gonna try to compile it. If it's good, and we're good to go. Okay, we have 2 errors, and let's go ahead and check it. We have the signal error. Let's check what is that. std underscore logic. Let's check what's wrong with this code. Okay, you know, this is a not okay, let's go back to the code. Remember, the logical value is supposed to have a quote, so basically it doesn't, this std logic thinks whenever I do without quotes, thinks it's a number, it's not a logical value. So if I put 5, it's something like 0, so it thinks that I'm trying to initialize it with a decimal value, which is not what I want. So basically you just use those quotes to make it to make the compiler know that we need a logical value of 0, not a decimal value of 0. So let's save this and run it again. Ignore, I don't want this, let's close it from here. I'm gonna compile it again, and let's hope for the best. We still have few errors. Let's just debug together. Okay, wait for 5 nanoseconds. We don't have a semicolon over here. Stupid mistake. Save it. Let's go ahead and check. Don't have any silly mistakes. Save, and let's just go ahead and ignore again. Just close this and hope for the best again. Compile. And last one is, let's check this thing. What is the last problem? 10 end process. Okay, this is a little bit weird. Okay, it's a still a silly mistake. I made it to be assigned, not checking. So this is a silly mistake again. So you check not assigned to the 20i. So just save it right now. Sometimes those silly mistakes can be a big problem, and the compiler won't give you a proper message. So let's check again and check it. I hope for not mistake again, and we still have a bit of errors. So let's go ahead and check them. We don't have a semicolon over here. Why am I missing semicolons? This is weird. I think when you program multiple languages, then it's just gonna be some. Okay, we have it ready. So we have it successfully compiled. Anyways, I think this is the test bench for it. Let me just go to it so quickly. Okay, we have the library included. We have the entity test bench, and yeah, the entity supposed to be empty because it's a test bench. The signal will be assigned in the in the architecture. So we have an architecture of the test bench. We have the inputs that we need and the outputs that we need. We initialize the input by 0. You can keep it, you cannot initialize it if you want, it's okay, because the process is already doing it for you. But I like it this way. It's up to you, just do whatever you want. Now G1 is gonna be an entity of a work where is A2 underscore Q3 ASM. The port is gonna be port mapped. The clock is gonna be clock I, reset I, 20I, and 10I as an inputs. Ready, dispense, and ret, which is return, and coin. This is the inputs and outputs, port mapping them and put them in the G1. So right now, assigning the values to the clock. Assigning values to the clock. We have a clock. It's gonna be 0. It's gonna change after 5 seconds to 1, 5 nanoseconds to 1. Change from 1 to 0 after 5 nanoseconds, and just keep repeating. That's how the clock is. And here we go. The reset is gonna be, and the first 10 nanoseconds is gonna stay stay 1, alright, because 1, then it's gonna wait for 10 nanoseconds, then it's gonna change to 0, then it's gonna wait forever. So it's gonna stay 0 forever. 20. The 20 signal, we are waiting for the clock. You can just remove this, but we check without and with a bit later. We're waiting for the clock when it's 1, then we're changing it to be 1 and wait for 100, then changing it to 0 after 100 and wait for 100 nanoseconds. The 10, we are waiting for the 20 to be 0. Once the 20 is 0, then we're gonna change it from 0 to 1. We're gonna keep it 0 for 15 nanoseconds. We're gonna change this to 10 nanoseconds. Change the 10 to 1 after 15 nanoseconds. I don't know what happened there. Anyways, so this is the test bench. Let's go ahead and test it, simulate it. Go ahead and go to the simulation, start simulation, open the work, and I think it's this one. Right, test bench. Let's go ahead and double click, double click it. State test bench. Alright, go ahead. Is it this one, right? Let's just make sure it's the right file we're testing. Let me just compile all again. Compile all, and just simulation, start simulation. Under the work, we have the test state test bench. Alright. That's a little bit weird. Let's make sure it's in the right location. Oh yeah, okay, we are in the right place. So let's test this. Go ahead and add to wave. We have okay. Let's go ahead and open the wave, maximize it. Just select all the I think I don't need to select all of them. Just click. Okay, let's make it this. Make this a little bit big. 1 new. Okay, 1 NS. And it's gonna be 1000. Just make it too big. Okay, just and zoom out and just check how the input and output changes. So let's go ahead and check. Oops, skip message. I don't know what happened. Anyway, okay, you can see the clock is changing, and the clock is changing, and also if you check here, the ready dispense is also changing. It depends on how the state moving. So basically it's ready means state A, and it's gonna go to the coin. It depends on which state is it. You have three states that needs coin. It goes if the 20 is 1 and 10 is whatever, is gonna go to dispense. When it goes to dispense, it's gonna go back to ready, and it just keep loops until the 20 changes to 0. Then it's gonna hold, because both of them are 0. It's gonna hold the keep stay in the same state because there's nothing happening. And if you insert 10, then it's gonna be a little bit different. It's gonna change. All right. So you can see the change over here. Okay. And you can just keep doing this for make it more precise. Change the nanoseconds. Change the weight statements over here. Wait 1 second. Change the weight statement over here until you find the best waveform that you can get. For me, this is fine, but I'm gonna just change this thing, just testing it along with you. I'm gonna save it, and I'm going to re-simulate it. I'm just gonna close this window, open model sim. I'm gonna go to the project again, compile the file again. I hope no mistakes. No. Okay, let's go ahead and start simulation again, and state machine, go ahead and press OK, go to the objects and click all of them and add to wave. Once it's added, go ahead and press the lucky button where you can see your waveform. Zoom out, and you can see it's a little bit different, but it still gives you the same thing: ready, from to coin to dispense, and so on. And you shall play around and see which best form you can get, and how many possibilities you can get. So yes, I think that's all for this video, and I hope you find it useful. If anything, you can ask me, call me or text me or anything. I don't mind. Sorry for the delay. I hope it was not so delayed. Anyways, hope you learned something today. If anything, you can ask me, drop me SMS, ask me in the class, and so yeah, see you guys.